Okay, so first things first, this is a continuation of something Prasad started last week, which was the certification drive that he did as part of the anniversary for Bengaluru Squad. And okay, it's cool to have a certification drive, but what's even cooler is to have some extra sessions to explain a bit more in detail how you can make the most use of those certifications, right? And this is how the idea came up between me and Prasad, doing multiple sessions after one another. And this is the second one, which is going to be mainly about just the CSWA exam specifically. You know, last week, if any of you guys joined us, and please let us know in the chat if you were there in the session last week, we were focusing more on the overall certification program, not any exam specifically, just the whole program in general, and talking about the different aspects of it. But today we're going to focus about one exam specifically, which is the CSWA exam. Okay, and as usual, massive shout out to Prasad for making this happen. So I think by now I don't really need to use this slide anymore. I mean, you guys already know me pretty much well, but yeah, the main thing here to get is that the first one. I've been using SolidWorks for quite a while, so and actually, fun fact. I think Prasad already knows this. I didn't take any exams for the first 3 years. Yeah, approximately 3 years, because I just didn't know about them. So it's super cool to have a user group in your area with an active leader like Prasad to let you know about these things at an early age. Now I see people who have been using SolidWorks for like 2, 3 months. They already know about certifications or are working on them. So that's a cool thing. But yeah, there was a podcast between me and Prasad. It's going to be announced soon, posted soon, hopefully, right, Prasad? Hopefully, where we, yeah, where we go a bit more in depth of my journey with SolidWorks. So if you're interested in that, you can check it out. Meanwhile, this is another podcast that it is already out right now that you can check. It's with the core podcast, Kirby and Johnny from the UK. They're also two user group leaders, and I was on their podcast a while ago. So you can check that from this QR code. It's a bit more about my journey with SolidWorks, how I started using it, and so on. If you're interested, if not, let's get started with today's session. Now, here's a bit of a disclaimer. I had a bit of a hiccup, and the original slides are not with me right now. They're on another device, and I lost my backup. So most of this session is going to be me showing you the stuff right inside of SolidWorks, not just showing you any slides or anything. First time doing it, hopefully it's going to go well. But this is what I managed to gather a bit in the last couple of minutes. And this is what we're going to be talking about today. We're going to start by explaining what the CSWA exam is for anyone who missed the previous session, or even if you did, but you just need like a reminder. So we're going to start by covering that. What is the CSWA? Why should you care? And so on. And then we're going to start talking about the exam itself. What information you should know about it before you decide to take it. Things like the exam details, what it covers, that sort of things. Not the exam questions and answers at all, obviously. And then we're going to talk about some tips and tricks for the exams. Some of them will be specifically for the CSWA exam. Some of them are going to be general exam tips and tricks. So be open to both. And then at the very end, we're going to check out the virtual tester, just in case anyone here is the first time for you to take an exam. We're going to see how the virtual tester environment looks like and what it looks like to actually take an exam inside of it. And at the very end, we're going to talk about, okay, what's the next step after I take the exam? What do I do? How do I see my certificate, or how do I post it on LinkedIn or stuff like that? So we're also going to cover that as well. Okay, sounds good? Okay, let's get started right now with what the CSWA even is. So the CSWA is actually the title that you get after you pass the exam. When you pass the exam, you become a certified SolidWorks associate. And the terminology here is really important because every word has a meaning. Certified, yeah, the SolidWorks, that's the software you're certified in. And associate is the level, because there are multiple levels of certification. There's the associate level, which is the first level of course. You've got then the professional level, and then the highest is the expert level. So associate, this informs you of the level of certification, and that also gives you some sort of expectation to what the exam level is and how difficult the questions are going to be like. And this is a bit more obvious when you look at the kind of official statement from SolidWorks about what sort of experience you should have before you decide to take the CSWA exam. By the way, this is general. It's not a rule of thumb. I've seen people who have taken like the CSWA in like 2 or 3 months from starting to use SolidWorks. But in general, it's about from 6 to 9 months mark. As I said, I took the exam after 3 years, not because I didn't know how to take it out or couldn't pass it, but it's just because I didn't even know that it existed. So that's the first thing. But we're now talking about why even invest your time and money, hopefully, in taking the exam. And for me, I'm coming back into the mindset of a student. Back when I was a student, why did I even bother taking these exams? Well, the main reasons for me were, one, it was a very easy way to showcase my skills. I don't need to show someone my skills inside of SolidWorks by opening SolidWorks and opening a model and showing him how I design it or anything. I just show him, hey, I'm a certified SolidWorks associate. I show him the certificate or even the badge that you get as well. And that's enough proof for him that I'm actually good enough in the software to a certain level, which is the associate level. The other thing is, in the exams, once you take them, and even when we talk about sample exams at the end of the session, you're also going to notice this. The terminology that's used in the exam is not the terminology of someone who's just like using the software just for the sake of using the software. It's actually the terminology of an engineer, of a designer. It's the terminology that you would use in the industry. So knowing how to understand that terminology, how it's phrased in the questions, and understanding it, and then designing the parts or the assemblies or whatever it is that you're going to design inside of software for the exam, that indicates that you actually know how to deal with the terminology that is in the industry. Okay. So in that case, it's not just a proof of your knowledge of how to use SolidWorks, but also how to use it in an engineering environment. And then the last one is, we all know that SolidWorks is like the industry standard software. So being certified in this software it's like putting you a step above the other students or graduates, if you're a graduate as well, showing that, hey, you're actually dedicated some time and effort into learning something that's widely used across the world, right? So these are basically the main things of why you'd even be interested in taking the CSWA. And once you finish this level, or even if you see that actually my level is even higher than that, then you can go to the next one, which is the professional one, and so on. After that, you've got the different levels or different scopes of certification. Now, when it comes to exam information, the main resource for me is always the official resource, which is the SolidWorks website itself. So that's where we're going to go. We're going to go to the SolidWorks website. If you go solidworks.com/CSWA, it's actually going to take you to this website. It might look a bit newer. This is a bit of an old screenshot. But anyways, if you just scroll a bit downwards, you're going to find a bit more detail about what the exam actually is. You're going to find a button to download the sample files. We're going to come back to this a bit later. You're going to find, which is really important, the minimum version that you should use to take this exam. In this case, it's 2011, so you're pretty much good to go. But for some other exams, it might be like 2018, 2019. So which is also not that new anymore. But if you're using any older version than the version specified in here, or I should say release, if you're using any release older than the release specified in here, you won't be able to open some of the files that it gives you. So when it gives you like a part to create an assembly of something, you won't even be able to open the part. So that might be an issue. But right now, 2011, I doubt if anyone's using 2011 or even earlier. So you should be fine. Let me know also down in the chat how many of you are using not 2015. You know what? Let me know what version of SolidWorks, what release of SolidWorks you're using right now. Personally, I'm using 2015. 2015, 2025. My bad. So yeah, I'm using 2025. That was like 10 years ago. Wow. So yeah, let me know which of you is not using the latest release. You also have some more information, which is really cool, because Now you know that the exam is 3 hours long, so you know that you have to set aside at least 3 hours to take the exam. Maybe you can finish it quicker, but yeah, as soon as the 3 hours mark is over, the exam is over. Which, by the way, it's pretty much, if you already got the skills and the mindset to take this exam, 3 hours is always going to be a bit more than you need. So don't worry about that. But you always have time to, if you mess something up, you still have time to go back again and fix it. And the last thing is the minimum passing grade, but that's not the things that we're here for. What we're here for is, if you scroll a bit down even more, about the exam section, this is where it lists all the different topics and features and commands inside of SolidWorks that this exam is going to cover for you. So when you look at, okay, it's going to cover like sketch entities, and it lists this and this and this and this, you already know that these are only the things that are going to be covered in the exam. You can use anything else, but don't expect the exam to require you to use anything other than those, and know that the exam can be solved using just these. If you use something else, that's fine, but there's a simpler or another version of the answer that does not use anything other than those listed in here. So, for example, if we take a look at like let's go with assemblies. Okay, at the very bottom you see the fourth from the bottom, standard mates. So if there's a question that requires you to use some mates, and you say, okay, how can I do this, and you end up using like an advanced mate, that's fine. But there is a simpler way to solve the question using just standard mates. So this is something to know. This is the same for any exam. Go to any exam webpage and see the list of commands that it covers. These are the things that it's going to cover in the exam. You can feel free to use anything else, but these are the bare minimum. Okay, but it has another thing, which is, let's say when I look at this list, I see, okay, it says, for example, drawing views at the bottom. Drawing views. What are drawing views? I've never used drawing views before, so in that case, I should take a step back, not go into the exam, not take it yet, until I actually learn how to use drawing views, learn what they even are, and then learn differences between them and so on, to be able to take the exam. If there's anything on this list that you don't, that you haven't used before, or you're not familiar with, or you don't feel that you're confident in your skills when using it, then in that case, I would say, hey, give it some more training, give it some more testing, and then after that, maybe give the exam a shot. Okay, enough about the talking. Let's go back again to SolidWorks, right? Because this is what we all hear about. So I've got SolidWorks, by the way. I just reinstalled SolidWorks. This is the fresh installation, no customization whatsoever. So I'm going to be struggling a bit. And let's now talk about the different things that we're going to see inside of the exam. So the exam, I kind of divide it into different categories or different stages. The first stage is the part modeling stage. You know what? Let me get this over here with me, just so that I can see the chat as well, just in case there's any correction. Okay. Oh, we have someone here using SolidWorks from 1995. I hope you're not still using it till now. I hope, because that's going to be a bit tough. I mean, Prasad can vouch for that. Both me and him, we actually used the 1995 release, and it was super hard. So
tough
yeah,
is the word I would use. Yeah. Tough is definitely not the word.
yeah, indeed. So yeah, let's get back again to SolidWorks, and what I want to cover right now is, as I said, I would kind of divide the exam into different sections. Okay, the first being the part modeling section, where you just giving some parameters, giving some instructions, giving some drawings and some dimensions, and you're asked to create that part. Okay, so there's a couple of things here. The first thing is, when you even start, before you even start inside of SolidWorks, I'm just talking about start answering the exam. The first thing is, this is the interface that you get. Okay, I've got everything blank, so don't worry. What you see over here is the interface of the virtual tester in the exam setting. Okay, so you've got over here, this is where the question is going to be. Okay, the question itself is going to be written here. Here you're going to find some images for reference to you, and you're going to find 4 choices that you can choose from. Okay, this is usually going to be like a numeric option or something, but that's not what I'm really interested in, because that's part of the question. Right now, I'm not really interested in the question. I'm really interested in the exam. What do I mean by that? Okay. So you see here, there's the previous question and the next question. What I want you to do is to take a bit of a moment, scroll through the exam, not necessarily the whole part of the exam, but maybe like the first couple of questions. Understand what the questions are asking you to do. Is it just asking you to design something, or is there going to be something else later on that same model that you created? Because that's going to help you understand what the design intent is, and in that case, understand how to better design the part from the get-go, from the beginning. Because you don't want to design something only to figure out in the next question that you need to edit something, and that edit is going to require you to do everything from scratch or delete some features or anything. You just need to edit it very simply, and that's it. So to actually be able to do that, what you need to do is to, from the very beginning, be able to create a robust model that follows the design intent of the exam. Okay, so just scroll through the questions. You can just go to the next question and the next question. Just read it, look at it, figure out what the design intent that the exam is giving you, and then you can go to the next the next step. So what would the next step in this case be? Okay, we're back again to solve this. Now, usually it's going to be creating a new part file, right? So let's create a new part file. And the first thing that most of us would start is usually going to go over here and create a sketch, right? Well, usually that's fine, but not in the exam, because in the exam, so for example, I'm from Egypt, okay? We use the millimeters as the main unit of length, okay? Some people in here might be from America, for example, and they use inches. And different countries use different units of measurement. And the exam might actually want you to use like an absurd one, centimeters, for example. Why not? So, so the first thing is actually to come down here. Let me actually zoom a bit. And from here, you've got the units. And what you have to do first is to set the units. So some of you might actually have this already in mind and say, okay, let me actually create some templates, custom templates that already have these units. And instead of just going and selecting the default templates of SolidWorks, I can actually select my custom templates. That's fine. Or you can just change it real quick from here. But remember to keep an eye on the units, because it's going to be specified in the question. And if you don't pay close attention, you might actually be like someone whose first name starts with Y, and then at the very end of the answering the question, you say, why don't my answers match any of the choices in the question, only to figure out that you designed the whole thing without the correct units. Okay, but don't worry, you can just use like the scale feature if you know how to use that, and just scale the model back to the correct size instead of recreating everything. But still, that's a possibility. So keep an eye out for the units, and usually starting by setting the units is going to save you a lot of hassle later on. Okay, so okay, we've got the units, everything's perfect. What's next? Yeah, okay, let's go and create the sketch. Well, not yet. Technically, you can, but there's another thing that it's usually listed in the question right after the units in the same area, and it's better to like finish this block of information at the beginning. So it doesn't start the question by saying, hey, let's create this, let's do this, let's do that. It actually gives you some general information. Hey, this is the units that you're going to use. This is the material that you should use, and so on. So I prefer to finish all of these, because if you don't use them all or set them inside of SolidWorks at the beginning, you might actually forget them. So you can go over here to the materials and then specify whatever material the question wants you to. If it's not in this list, it's fine. You can just go to edit material and then search for it. So let's say I want gold, for example. So yeah, pure gold. And I applied it, and that's fine. So that's cool and everything. I've got the units, I've got the materials. I should be pretty much good to go, except that there's one more thing, which is to make sure that the exam is actually different from one taker to another. What happens is, let's say, for example, I take the exam and Prasad is sitting right next to me, and he's also taking the exact same exam. We're going to get different questions with different numbers and different answers, different everything. Why? Because there's certain variables that have to be set in the question first. And there's like a program or an API in the background that's just changing these different values, different variables. And based on that, calculating what the new answers are going to be for me and for Prasad. right? So that's a cool way to make sure that everything is streamlined, everything is easy to be created from the exam standpoint, and also for us to challenge us on another thing, which is equations. Because I can come over here and I can do a sketch on the front plane, and I'm going to be very slow right now because I never go over here to get a rectangle. It's always on my keyboard shortcuts. So yeah. Anyways, let's say for example I want this to be like 100 by 50. Okay, so I'm just gonna type in 100 by 50. That's fine. But if I'm later on going to change it to like let's say 75 by 25, well, it might make sense to actually put that as a variable. Maybe I'm not sure. I mean, it's very easy to go back again and change it, right? So what if I say, okay, you know what? Let's go and create an extrusion for me. Okay, and this extrusion, I don't want it to be like a number. I want it to be linked to like this 100 or this 50. I can say like equals, doing an equation right now. I want it to be like this 100 divided by 2, for example. Okay, so it's always going to be this number divided by 2. That's an equation, right? And to make sure that you kind of follow me here, if I go over, these are regular equation, regular dimensions. If I click on this one, you see this like sigma sign. This is the indication of an equation. Okay, this tells me that here this dimension is actually an equation. And if I change this 100 to like 75, this one is also going to update to 37.5 and so on. So right now I'm just using equations. I'm not doing anything with variables. But the thing is, what's this 75? How do I reference it later on? If I come over here and say, hey, I want to like an extrude cut, for example, and I put the circle, and I want the diameter to be the same thing. What do I type in here? Do I type dimension 1 and sketch number 2, or was it sketch number 1? Or, I mean, that's a bit of a hassle, right? So that's why the exam actually gives you some equations to use. Okay, so right in here, you can do it right from here. I can say like A, and it tells me, do you want to create a global variable? Okay, and I would say yes. So it's A, and in this case, A is going to be 75. Okay, maybe that's a bit too much, but hey, that's fine. Anyways, let's go with equals. Once again, now look at this drop down menu. I see global variables, and I've got A inside of it. Okay, so now I can actually link it to a global variable. In this case, I might actually do it another like A divided by a number or something, because A right now is 30. Let's keep A by 75. Let's go back and get to the equation. I'm just toggling the equation view and the dimension view. Let's go with A divided by 2 as well. Okay, so the same thing. Okay, I'm going to exit the sketch. So far, it's fine. I mean, this is very simple. But remember, what I'm trying to do is I'm trying to maintain design intent. And design intent, it's not my design intent, it's the exam design intent. So if I go back again over here, this 75 dimension, well, you can also come back again here and say, I want this to be equal to A. It's also going to be the same value. But the cool thing here is, let me now come again to this equations dialog box over here and right click and manage equations. And I have a view, it's on the wrong screen over here, that tells me, okay, you've got this variable, 75. If you want to change it, I only have to change it here. And it's going to populate everywhere else. It's going to populate in this dimension for the, okay, not this one, okay, the sketch for this one and that one. But here, if I want to change it, it's actually referencing dimension 1, sketch 1, which is over here, which is referencing A. You see, linking a dimension to a dimension, it's fine, it will work. But it's not easy to remember which one is the master one that I should change in order for the others to follow. So the easiest thing here to do is to actually change this to also A. And just like that, all I have to do now is just change the global variable and all of these will follow. If I change this A from 75 to like 50 and I hit rebuild, now look at these values that evaluate. It didn't change to 50. Let me go once again. Now it's 50. And as you can see, 25, 25, 50, right? So it's way easier to have all of these values in the same view over here. And I can also come over here and say, I want to create B. B can be like 67.5, because why not? And then I can go with, let's say, C, which can be 2025, And I can also create D, which can be 1995, because also, why not? Okay, so just like that, I've got a couple of global variables, and since I've already created them beforehand, I can just go ahead and create any sketches or anything. Let's do something here, maybe a sketch. And let's say I draw a line like that. If I give that line a dimension, as we saw earlier, as soon as I hit equals, I have that drop down menu. So I just move it equals global variables, and I've got the whole list to choose from if I want A, B, C, D, and so on. So I can just choose the number, and there it is. So that's a cool way to link everything together. And once again, to make sure that when you change it later on, when I change A and I change B and I change C, I don't have to remember where did I use that 50 dimension? Was it in the extrusion? Was it in this sketch? I don't know. I don't care, because everything is saved by SolidWorks in the equation dialog box. What I have to do is just go and change that value from one place, and it's going to populate everywhere else. Okay, so this is the next step that I usually do. I go ahead and make sure that I've got the units set up, I've got the material set up, and then I've also got all the global variables set up so that I can just start using them right away inside of my sketches. Okay, or even features. Okay, let's exit this one. And now let's talk about the next thing, which is I've got everything set up correct. I've got the units, I've got the material, and I've got the global variables. Now what I can do is go ahead and start creating the model, right? That makes sense. But here's one thing. Usually we start by sketches, right? Usually everything is based on a sketch, and then the sketch is used later on to create a feature. But not all sketches are alike. Because you see this sketch? That's a nice sketch, and this also is also a nice sketch. You know what's not a nice sketch? Let me show you what's not a nice sketch. I'm going to come over here. Do a sketch. Let's say I want a circle to be maybe over here, and I want that circle to be like 15 millimeters. That's what I'm going to do. I'm going to come over here and put a 15 millimeters dimension. Perfect. And I'm going to, let's say, do a extruded cut. Okay. So just like that, I can do my extruded cut. Let's do it through all upwards. And cool. Right? Everything is cool. Does anyone have anything to say? I created my sketch, and I also created my feature with it. And SolidWorks is not angry with me. The goal is there, but I'm angry with myself. Why? Because you see, this sketch, when I work with it, someone's saying it in the chat. Yeah, it's not fully defined exactly. So this sketch, when I'm editing it, look at this corner down here in the status bar. It says fully defined, and that's what we want. We want our sketches to be fully defined. And as Tutorial says, fully defined every time. There's another way to know if your sketch is fully defined or not, which is also from the feature tree over here. See this? That's what the sketch should look like. See this minus sign? That minus sign means that it's underdefined. We don't want underdefined, because even when I edit a sketch, if I look over here, it also says underdefined. That's not good, because what underdefined means is that I can just come over here and now I know drag this around, move over here, there. There's nothing that controls it, nothing that says, hey, you should be fixed in your place. Unlike if I say, for example, you know what, let me grab the dimensions, put a dimension from here to, let's say, over here. Let's say I want this to be 25. Maybe even link it to a global variable or something, I don't know. And then maybe from top, you don't have to do it to this edge, not to the circle. You hit shift. That's a nice thing. You hit shift and select this one, just like that. Let's say 5. And just like that, I've now got a fully defined sketch. Now it says fully defined, and there's another way to know it. Do you know why? So I mentioned the icon over here, the sketch. It doesn't actually say anything between brackets, just sketch name. And it says also down here in the status bar. There's one third thing. It's more of a visual thing. Do you know what the visual thing is to indicate if this is a fully defined sketch or not? Let me make it a bit easier for you. I'm just going to delete one of these dimensions, and you're going to figure it out. Okay, close dimension. What changed? Yeah, just as Christopher says. Christopher, you're correct. It turns black. So right now it's blue, which means it's underdefined. If I bring that once again, it's now back. So the sketch itself is now fully defined. That's another thing. As I said, you have to make sure that everything is fully defined, because that means that all the details that the exam gave you, you're now correctly conveying them inside of SolidWorks. And on the other hand, let me just delete all of these, because you don't have to use dimensions for fully defining your sketches. I can do something like this. I can come over here, choose a center line, and just put the center line from this point to that point, and say, you know what? I want this circle. Right now, this circle can still move around, right? I can just put a relation between this and that, maybe midpoint, and now it's also fully defined, right? So there are multiple ways to fully define. Maybe using dimensions, maybe using relations, maybe using both, mix and match. But the main thing is, once you fully define your sketch, you can't hold something and drag it around by mistake or anything. Everything is perfectly in place, okay? And it's not perfectly in place by using the fixed relation. So I don't come over here and say, hey, let's maybe display delete relations. Yeah, select all, and then go delete all. Everything's now this, and then Control A, select everything, fix. Well, it's fully defined, right? Yeah, it says here fully defined. It's black. No minus sign over here. That's fine, right? Well, no, because I can't edit it. I can't say, hey, this should be a bit longer, a bit taller. What's longer and what's taller? Because there is no dimension to change it with. But when I have fully definition with the correct relations and dimensions, I can easily come over here and say, you know what, this 50 actually needs to be 60, and so on. And it's still fully defined, but I'm still able to change things about it. Okay, so this is really important. Maintaining fully definition at the same time, all the dimensions and relations and design intent that the exam tells you to use, still used in the exam. Okay, so this is the next part. We make sure that all of our sketches are fully defined. Now, all we have to do is start by creating our features. And we've already created a bunch of features over here. Maybe if I'm in an exam situation, I might create this a bit different, because, you know, this extrusion, it's from the front plane. And this cut, I mean, it's also from the front plane. So what makes me do it like that instead of just coming over here, maybe changing the sketch and like putting the circle right in the middle? I mean, I can still put dimension, and it's also going to be the same thing, linked to my global variable divided by 2, just as I want it to be. And then I can exit the sketch, and I'm pretty much going to get the exact same result, right? It was just in one feature instead of in 2 features, right? And this is another thing. The choice of your features is really important. You know what? Let me open another one. Let me open this one. You see these 4 cylinders? Let me know in the chat what you think are the features that I used to create these 4 cylinders. What do you think? And Prasad, let me know you as well. How would you create these cylinders? Extrude. Okay. So you draw a circle and then
I'm going
extrude,
with the
right?
PSW A level now. Yeah, I just create the circle and and I would extrude them. I mean, I would rather extrude all of them together.
John actually agrees with you. John also says extrude. Christopher says extrude. Everyone's saying extrude. Okay, cool. So you're not wrong, but you're also not right. Okay, so you see this first one. It is an extrusion. I had this scroll down here and then I extruded it by 10. So it's an extrude, right? But you see this one. Well, this is actually a bit different. This is a revolve. I had this rectangle and then I revolved it around the axis. Don't ask me why. I'm just explaining something here. Is that both circles, they created both cylinders, as I should say. They gave me the exact same end result, but they were created with totally different ways. What do you think this one? How do you think this one was created?
Another
Another extrude? Well, actually no. I've got a line, I've got a circle, and I created it with a sweep. Not the best choice, I agree, but still, I got the same end result with a circle and a line and a sweep between them. Okay, I think you guys now know where this is heading. The 4th one, what do you think this is going to be?
Loft.
Yeah, exactly. So this is a loft between 2 circles. Okay, so definitely not the best choice, but I'm just explaining that I've got 4 different features that gave me the exact same geometry in 4 different cases. So what I'm telling you here is this. You've created the sketch. You've built intelligence in the sketch using the equations, using the variables, and so on. Make sure to follow the same intelligence and create the right features for the right model, because you can create different geometries using different types of features. In this case, all of these cylinders are the exact same dimensions, the exact same volume, the exact same mass, everything, but I created them in totally different ways. One of them is really quick. One of them is a bit slower, but maybe easier to change, maybe. One of them has the exact same dimensions as the ones in the drawing. The drawing said it's a radius, not a diameter. So here I used the radius, not a diameter. Maybe. And one of them is just absurd. I created 2 circles and a plane, and it doesn't make any sense. But that's the thing. You have to know which is the best feature to go with, regardless of what intelligence you created, because the intelligence that you put in the sketch is not going to follow unless you actually chose the correct feature. And once again, there's no right or wrong, just the best option, and slightly less better, slightly worse, and so on. So once again, as I said, when you look at all of these, this one, only one sketch. I put the diameter, I gave the height, and that's it. For the revolve, I actually had to draw a rectangle. This 5 is not the one on the dimension, for example. Maybe the dimension says this is the diameter, but I put 5. I had to do my math in my head. 10 divided by 2 because it's a radius, so that's 5. So I did it like that. But it's still fine, one sketch, not biggie. But remember, which is easier to define? A rectangle with 2 dimensions or just a circle with a diameter, right? 1 dimension. And then it comes to the sweep, where you have to draw a line, a circle, create it like that. I mean, technically you don't have to use the circle, because in 2016 and higher, you can just come over here, use the circular profile, just enter the profile over here. So in this case, it might actually be a good one. I just draw a line, 10 centimeters, go to sweep, and just like that, I already have the shape that I want. As you can see, just like that. And I didn't even use this sketch. I can now delete the sketch just fine, you know. But that's the thing. You are the one who's going to decide which you're going to go with. And then at the very last, and we've got the loft, we've got the bottom sketch and the top sketch, and just never do use this one. But what I'm trying to say here is this. I'm not trying to say use a sweep or use a revolve or use a boss extrusion. What I'm trying to say is use the best in that situation. Who's going to know? You're the one who's taking the exam. You're the one who's going to say, okay, in this situation, it's better if I maybe create one circle and then do a linear sketch pattern and then extrude all of them. Or maybe because I know that sketch patterns are a bit higher in performance cost, and they're worse in performance. They slow my system down. So in that case, I actually might do just one circle, one extrusion, and then do a linear pattern of that extrusion, because from my experience, I know this. So that's what you have to do in your mind. You have to decide which route is better. Once again, all of them are going to give you 4 cylinders, but which is the easiest, which is the fastest, which is the easiest to model, which is the easiest to edit, and so on. You have to take all of that into consideration. Okay. So that was it when it comes to this part. And the very end of the part modeling section of the exam is you creating the part, you then making sure that everything is correct by supplying the software with the results. Okay. And we're going to talk about how that is done in a moment. But first, we've got to talk about something else, which is the modification. I think we've already hinted on it earlier. Is that let's open like a feature like this one, for example. This part. Okay. How easy do you think is it for me to edit this component, given that it's not me who designed it, someone else designed it? I've got some names over here: base extrude, cut extrude, cut extrude, cut extrude, post extrude, and so on. It doesn't really convey any information, but at least if I go one step at a time, I can understand how it was created and follow along, right? So this is really important. Since you're the one who's going to be creating this part, maybe you're going to create it in a different way. But remember the very first tip I started with, to go ahead and check the whole exam and see what the different questions are asking you to do now and later on. Well, that's really important here because now when you're asked to, make this a bit longer or change this radius to another value or change the position of these two holes, how easy is it going to be for you to do that change? Is it just going to be one dimension to change, two dimensions to change, or you have to remove features, suppress features, add features, and so on? That's really important because once again, it's a timed exam. You've got 3 hours, maybe not too much. For others, it might be way too much. It depends. But the main thing is, if you don't actually use those 3 hours correctly in the best way possible, you actually might end up running out of time. So it's really important to make that one of the highest priorities that you have while you're designing, which is the design intent. And once again, it's not your design intent, it's the exam design intent. It tells you what to do and what to change later on. So you have to follow what the exam wants, not what you want. Okay. So that's cool and everything. We've got our part designed, we've got our modifications created, and now comes the time for the changes in the assembly. So now in this part, we've got a couple of different things. We've got a couple of components that you're given, probably like a zip file that you have to compress first, and then you are asked to create them in an assembly file and assemble all the components together. And it usually tells you which parts go where and so on. So this is an example, for example. This is a part that can still move, that everything is assembled, as you can see. And assemblies are one of the areas that you actually have to have it fully defined right away. Later on, maybe at the end of the assembling process, when it tells you, this should be like here, this should be there, maybe by then it's fully defined. But when you're still creating it, it's fine to have it still underdefined. But the main thing here is this. Where is this assembly in 3D space? And that's a really good question because when I'm talking about parts, I'm usually more concerned about, is the geometry correct or not? Is the mass of the part correct or not? Is the volume of the part correct or not? When I'm talking about assembly, it's actually quite different. I'm actually more concerned about all the components together. Are they mixed together or assembled together in the correct form or not? And that in relating to like the environment around it, or that's according to where it is in the 3D environment. So it's really important to, from the very beginning, to think of the origin, the reference, the main reference that everything is going to be set up according to. And that's really obvious when you create a new assembly set of SolidWorks. When you go ahead and start by adding the very first component, some options over here. So you see, if I scroll a bit down here, you see these options. Let me just zoom in a bit. You see, fix and float the component on insert. It tells you only fix the first component, or all of them, or float all of them. This is really important because many people will just fix it. And wherever that first component goes, that's where you are. I'm just going to like assemble everything around you, regardless of where you are, how you're oriented, and so on. That might be fine when you're just doing a quick demo of something, but not when you're in an exam where everything is supposed to be precisely according to the question that you're given. Because in this case, what you actually end up having is you have a first component that should be oriented or put in a certain area or a certain position. And then the other components have to be assembled according to that position or that first position that you hopefully have created correctly in the first place. If you haven't, then everything is assembled correctly, but not to the correct reference. The origin is in the wrong place, it's in the wrong orientation, and so on. So this is really important. When let's say, for example, I grab this component and I want to insert it. And remember, what for the very first component, maybe I put it over here. Okay, that's fine. That is fine. As you can see, this F mark over here between two brackets, this means that it's fixed. I can't hold it and move it around. But that's a very easy fix. I can just right click and say float. So just like that, now it's float. As you can see, now I have the minus mark between the two brackets. It's also underdefined, as you can see over here. Now I can just hold it and move it around if I want to. And let's say, for example, here's the origin. Maybe I want the origin to be at this point. Maybe I want it to be at that point. Maybe I want it to be at this point. Whatever the exam tells me to put it, I'm going to put it. So this is really important because it was in another arbitrary position but that's not actually what we want. And maybe it's actually exactly where this origin is. In that case, there's a very cool thing, which is if you have a coincident between two origins, let me not do it from here, which you can. I'm just going to do it from the mate command manager because I want you guys to see this. Okay, so when I put it like this, you see this option, align axes. You don't have that option when you just select any 2 points or any like point in a line or line in a line or face in face and so on. You only get it with origins together. So align axes means in general that you're going to have the front plane of the pod aligned coincident to the front plane of the assembly. You have the top plane of the pod aligned with the top plane of the assembly and the right plane of the pod with the right plane of the assembly. So you've got everything with the three main planes are going to be coincident with the three main planes of the assembly as well. And in that case, when I hit OK, let me just put this one. Now it's also fully defined, not fixed. And I can't actually move this around. And by the way, if I go over here to the mates, and if I disable this, this is how it's going to look like. Let me disable this align axes option. Okay, so I'm just going to disable it, hit OK. Now it's back again under defined. It can't move, but it can rotate. So this point is fixed, but it can still rotate around it. So this is really important if you want to save yourself a couple of clicks. If you don't want to like do 3 mates, you can just do 1 mate, just coincident mate, and then just have everything set up to that. But once again, remember this is only between origins. So to have this, you would make sure that you actually need the origin of the assembly with the origin of the pod. Because let's say I come over here and let's say I want the origin of the assembly. Let's say with this point, I don't have the align axes option. And in that case, it's just a regular coincident between a point and a point. And in that case, it can still rotate, as you can see. Okay, so this is really, really important. Okay, so now all I have to do now is just go ahead and start adding different components, mating them together, and so on. And hopefully, you've got everything set up correctly. So let me get back again to the assembly that we had over here. We talked about the origin. That's the first thing. See, we've got a question over here. Is it better to make every part with center as origin? No. The better option is to see what the exam is asking you to do, because the exam is going to tell you, I want the origin to be here, I want it to be there, and so on. So the best option is to follow that, and many have been guilty of this. Not me, but the thing is, if you put the assembly in a different location, but the assembly itself is correct, you're going to end up with incorrect answers. You're going to have wrong answers, even though you've assembled everything correctly, because you have the wrong reference. So make sure to follow the origin that the exam tells you. The exam might tell you that the origin is arbitrary. In that case, you can put it wherever you want. In that case, it's fine. In that case, I always do so this is not an assembly I created, but what I would do is just go over here, float, and then just get the origin of the first one with the origin of the assembly, make them together, and just like that. I always prefer to use mates and relations and dimensions, and never use the fixed relation or the fixed dimension or the locked dimension and stuff like that. Okay, it's obviously a personal preference, but it makes it easier for me to later on come and say that, okay, I want to suppress a mate or unsuppress a mate and deal with it in that case. The other questions, can we do this between a face and an origin? No, it's only between an origin and origin, not even a point and an origin. I've just showed it right now. Not any 2 points. It has to be 2 origins. Okay, because once again, origins are what have planes referenced by them. They have front, top, and right planes referenced by that origin. So when you say I want these 2 origins aligned together, what it really does is says, okay, this is the x direction or the x direction, the y direction, and z direction from this axis. This is the same for the other axis. Align them together. Okay. So that's what it does. So back again on track, we created the first component in the assembly. We added it. We put the origin exactly where the question wants us to put it, and then we added some mates. And remember what I mentioned earlier. There are different types of mates. We've got standard mates, we've got advanced mates, we've got mechanical mates. But this exam is mainly concerned about standard mates. So we're only talking about like coincident, parallel, perpendicular, tangent, concentric, not the lock mate, and distance and the angle mates. These are the ones that you're going to be using. I'm saying not the lock mate because it doesn't really serve any purpose. It just means stay where you are. There's not really any definition. It has to be like with a value or with some sort of intelligence in it. Okay. But once again, as I said, if you go over here to the advanced mate and say, okay, you know what, I can actually do this with a width mate or the symmetric mate. Yeah, you can do that. But remember, there's a simpler way to answer that question that doesn't actually require you to do that or to use another type of mate. For the CSWA, all you have to do is just use mates. And that actually makes it easier for you to think about it. Okay, now we've got the origin where it is, we've got the mates, we've got all the components. The last thing to deal with right now is to make sure that everything is working correctly. So what I have over here is that I can actually start like dragging components around and see, okay, is this movement right or not? Is this actually what I expect from it or not? Okay, and based on that, I can say if I've got everything right or not. It's not going to tell you, hey, hold this component and drag it around, but it's good to do that just to make sure that you've got everything correctly. Because let's say you have some missing mates in here. Let's just come over here and suppress some random mates. But it's obvious once I do this that something is wrong. And in that case, okay, I forgot to add this mate or I forgot to add that mate and so on. So it's easier to see if everything is working correctly when something is in motion. And it's usually going to be the biggest type of movement that you can, movement that can actually affect multiple components at the same time, as I'm doing right now. So when I'm moving this arm, it's actually moving the other arm, these bolts, these washers, these screws, this rod, and so on. So everything is moving as well. So it's really easy to showcase visually if everything is correct or not. If there's something incorrect, make sure to fix that before you actually answer the question. Okay, that's actually a good way to jump into the next part. We talked about part creation, part modification, assemblies. The next thing is answer the question. Okay, what kind of question am I going to expect? Now, it's going to differ depending on what kind of question you have. So, for example, let's go back again inside of a pot. Okay, right now inside of a pot, fine. What it really needs me to do is to make sure that I've got the correct units, I've got the correct material. That you put any material, let's say aluminum, why not? Okay, now when you come to the point where you actually have to answer any question, you're usually going to be looking in one of two places. The first is the evaluate tab. If you don't have it, just right click, tabs, evaluate. Okay, and specifically inside of the evaluate tab, you only need two commands. You need the measure and the mask properties. Okay, measure is, as it says, it's just a general handy tool to measure pretty much anything. It can measure diameters, it can measure distances between different faces, it can measure angles, maybe between angled faces, it can measure distances between circles or cylinders or holes and so on. It's really versatile, but you do actually need to launch the measure command every single time, because in case you haven't known, if I click here, control select and click here, I want to know the distance between these two. I don't actually have to open the measure command. All I have to do is just come down here to the status bar. It says the normal distance is 3.5 inches. Just like that, I know what distance is. If I just click on this circle, it tells me over here the diameter is 0.5 inches. The same thing if I go, let's say, for example, from here to here, it also tells me, okay, distance between cylinder axes is 2.305 inches. So most of the time, I don't actually have to open the measure command. Most of the time, I actually have all of the measurements that I need already presented to me over here. And this is the same for like lengths. I can just click on this edge. It tells me, okay, this is 4 inches long. I can select this top and bottom face. It tell me, okay, the thickness or the normal distance is 0.25 inches and so on. So this is a really cool tip to save some time for yourself, and you don't actually have to go to the measure tool every now and then. You can do everything just from the interface itself. Okay, and not just lengths or distances. Let me get this one, for example. So this component, I think we've got some arbitrary angles that we can also use. Yeah. So if I select this face and this, now it tells me the angle between them is 75.8 degrees. So not just distances, not just lengths and so on, not just diameters or radii, but I can also get angles. Speaking of radius, I can just click on this radius over here. It tells me, okay, this radius is 0.21 inches, and so on. So it's really versatile. Give it a shot. And get yourself used to using it just from the status bar instead of actually going to the measure command, which is actually fine, but that's another thing to consider. So it can ask you about that. It can ask you about lengths of different things. Where is this component relative to this component? What's the angle between this face and that face, and so on. Or it can ask you about the mass. And when it comes to mass, definitely you're going to go to the mass properties command, which is also on my wrong screen. And here you can, it's usually going to be in the same units that you have in your part. So if you're creating a part in like millimeters, you can expect the mass to be in grams. If you're creating it in inches, it's probably going to be in pounds, which is LBS for some reason. But yeah, the main thing is remember to have the material selected correctly, because the material is going to affect the density, and the density with the volume is going to affect the mass. Okay, so what you have to do then is just get the mass and put it in the question. And this is a very important thing, because usually you've got multiple questions, right? We said that we have a question and to design something, and then you actually modify it later on. Let's go back again to what that actually looked like. So this is what it looked like to answer the very first question. For example, in a series of questions, gives you a part to design, you have 4 options to choose from, which is actually good for you, because in that case, all you have to do is just make sure that your answer is exactly spot on one of the 4 that you have. And if it's not, then there's something wrong with your design. You can, in that case, go back again, tweak it, modify it, and make sure that it's correct in that case. But the tricky part comes when you solve this question and you jump to the next question, and you find this text box. Please enter a value. In this case, in the CSWA, you only have a 1% margin of error. So for example, if the mass was 100 grams and you entered 99, you're good to go. If you enter 101, you're also good to go. If you enter 98, nope. 102, nope. And obviously anything higher than that or lower than that, you're also not good to go. So in that case, you have to really make sure that you've got the very first one, which is actually based on choices, correctly, 100% correct, because that means that at least at this stage, everything is perfect. When you build on that and do some modifications, you have a less chance that you might mess up something. And in that case, when you enter a value as a written value, in that case, you now have a higher chance of making sure that your answer is actually correct. Because if there's a slight error in the first question, it's actually going to change or affect how the second question is going to be as well. And that effect might actually at some point be bigger than the 1% margin of error that you have. So that's something to keep in mind. Okay. So now we're talking about the different styles of exams, or different styles of questions. You've got the answer that you select. You also have the answer that you enter. Make sure that you actually enter the correct answer, because, and most of us have been there before, where you actually design it correctly. You go over here to the mass properties. You see, okay, 0.012. And then when you go to the Tangix tester software, or you enter the value, for some reason you use that fat finger or hit the wrong button, or you say, okay, 0.013 or whatever, and you just enter the wrong value, and it really is a bad feeling knowing that you actually designed it correctly, or you actually messed it up instead of entering the value. So if you want, you can just like do this, right click, copy, and then in the exam, Control C and V won't work, but right click, copy and paste, that would work. So in that case, you can just go ahead and copy and paste if that's something to make sure that you've got everything correctly and you don't like enter the wrong value. Okay, so yeah, that's one more thing to keep in mind. So yeah, we pretty much covered the basis of the exam. We talked about what we have when it comes to part modeling, what the sequence of our thought should be, and then when we come back again to modify it, if the part modeling process was correctly, that's going to help us a lot in the modification process. And then when it comes to the assemblies, well, whether it's talking about where the assembly is going to be, how the movement is between the components and each other is going to be, and so on, you have to make sure that you've got that correct as well. And at the very end, when it's asking you to extract information from the software, to make sure that you've actually designed everything correctly. Either going to be dimensions, distances, angles, and so on through the measure or from the status bar, or when it comes to the mass properties, you've got the mass over here, which heavily relies on you choosing the correct material. But that's not all, because once again, remember when I mentioned the origin, the assembly? Let me just close this component, come back again here to the assembly. Let's put it at maybe this location, and let's go over here, evaluate, and go to mass properties. Okay, let's rebuild it. And now it tells me that the mass is 184. See, that's one of the issues that you might have. You might just say out loud the wrong value, and when you come back again to enter it in the exam, you just say 0.16. So yeah. Anyways, so it's 0.184. What happens when I change this over here? What do you think is going to happen when I check the mass once again? Is it going to differ? Is it going to change, increase, decrease? What's going to happen? Let me see. Okay. No, I don't see any answers coming in. Nothing. Okay. Yeah, exactly. You're correct. Nothing's going to happen because I didn't change any design elements. All I did is just moved it around, right? Yeah, just as Jan and Christopher and John said, mass would stay the same. But you know what didn't stay the same? So the mass is the same, the volume is the same, even the surface area is going to be the same. But the center of mass, that's not going to be the same. So in this case, it says 2.5, 0.6, negative 0.001. Okay? Now, try to remember these values. I'm going to drag this all the way over here. Mass properties, 2.3, 7, 0.143. Totally different values, right? And this is where what I was talking about when it comes to the origin really comes in handy, because right now it's referencing this origin, the assembly origin, okay? If this origin is in a different area, so I'm not going to actually change where these are. What I'm going to do is just come over here to that, where is that coincident made that I created? This one. I'm going to suppress it, okay? And I'm going to make sure that everything moves as it is. I'm just going to move it. Oh, okay. It's not actually going to move as it is. Let me just fix it in place. Where is the rotation mates that it has? Yep. Let's lock rotation for that. Let's also lock rotation for the other concentric mates, just to make sure that nothing rotates or changes its position at all. Okay. So I'm just right clicking, locking the rotation, making sure that these concentric mates stay fixed in their place. Okay. Yeah. So right now, once again, what is the mass? It's this value. You know what? I'm just going to put it in the chat real quick. Okay. Remember, you can also right click and pop to. So this is the mass before. Now let me just move this around. As you can see, these are not moving together, right? The angle didn't increase, this didn't go in and out, nothing changed. All I'm just doing is changing where it is. Instead of being on the left, put it on the right, and that's pretty much it. Now when I go to the mass properties, yeah, rebuild. Now it's totally different. Let me put that in the chat as well. And you guys can compare. Well, X has increased by like 1.5, Y has increased by 1.5, and Z has increased by like 3. Right? So that's what it means by the reference. The reference is really important. I can say, okay, I want this origin to be at this origin, but maybe that's not what the exam wants. Maybe the exam wants this right plane to be with this face, and maybe it wants this front plane to be with this face, maybe, and maybe it wants the top plane to be with this face, right? So in that case, what I have here is I've got the origin. The model looks the same, but the origin is at this point. And now when I go to the mass properties, a different number. Okay, so it's really important to make sure that you've got the reference correct, because even though the assembly itself might be correct, all the components are mated together, everything is in the right position, but you're referencing the wrong origin. Okay, and this is also to answer the question that we had earlier when it mentioned if is it better to make every part with center as origin. No, the best option is always going to be to follow what the exam asks you to do. If it tells you it's arbitrary, then it's fine. If it doesn't, then you have to follow the question. Okay? Okay, so far I don't see any other questions in the chat. And this is now the part where we would actually take a look at the virtual tester. Okay, so let's go ahead and get that ready. And while I do that, feel free to put any questions, whether it's about what we discussed or about anything else related to the exam, in the chat, and I will make sure to look at it in a moment. Let me just open the virtual tester. Okie dokie. Okay, let's close SolidWorks. And now here's the virtual tester software. And one might ask, okay, where did you get that from? Well, it's super easy. All you have to do is come over here to the website I'm going to track right now. It's 3dexperience.virtualtester.com. Let me put it over there. And it's also in the chat right now. Let me just, okay. Like that. Okay. Now, if you go to the home page, okay, this is what you're going to get. And if you go over here to the top right corner, this is where you download the virtual tester you use to take any exams. Okay, so when you download it, you get this file. You can just double click it to run. And it's actually pretty simple to install. It just gives you this. Okay, yeah, I agree. And as you can see, it's just like 30.6 megabytes. Pretty small. Let me just install it real quick. And it's going to be done. Okay, I don't want to run it just yet. Let me just hit finish. And of course, it's on the screen. So here it is. So this is what you get when you install the virtual tester. Okay. Oops. So what you get is a folder. And inside that folder, you're going to find this exe file. This is the software that we use to take an exam. So all you have to do is just run that file. Okay. And notice what you have over here. You see this log file? This actually documents everything that you do while you're taking the exam. Everything from the moment you start this software, this exe file. So here it is. So to be finished. So let me just exit right now. Just run it once again. It's actually going to create a new one. And this is actually for your benefit. So as you can see, there's the new one. This is in your benefit because let's say, for example, you're in the middle of the exam. Suddenly, SolidWorks crashes, or your internet connection fails, or maybe disconnection, or maybe Tangent Tester itself fails, crashes or something. Maybe like someone trips on the power cord and your laptop dies or whatever. Well, how do you prove that you actually were just about to submit that final question and I actually answered everything correctly and so on? Well, through the log files. The log files is the way to prove that you actually did create your course and actually answer a couple of questions and you're actually on the right path to finish the exam. So in that case, you just take that file, send it to the certification team, and in that case, they would see what to do in your case. Maybe like give you another opportunity to take the exam. Maybe if you're already just about to submit and you've got all the answers correct and they can see that, maybe they can just give you a certification. They're going to do what they see best. But once again, make sure that you have that log file because you're usually going to be asked to present it or to send it over if something like that happens. Anyways, what you got to do right now is just go over here, log in. Obviously, you must have internet. And then after that, you just create an account or log in with an account. I prefer actually if you were to create an account over here, on this website, not inside of the software, because it's just easier and you just get an email after a while to verify your account first before you can take any exams. Here, you kind of think that you're just going to enter right away, but that's not the case. So if you have an account, just make sure to just enter the details over here. If you don't have an account, you can create one in here or from the website. Both are the same thing. Remember, you see this option list in online directory of certified users? Check it. We're going to talk about that in a moment, but yeah, check it. Anyways, I'm just going to log in real quick. I can't type today. I have no idea why. And please don't look at my password while I enter it. It's super secret. Anyways, Now we're inside of the virtual tester. As you can see, it's like a unified tester for multiple exam types, whether it's from Solux brand, Delmia, Novia, Katia, DraftSight, or even 3DExcite. Anyways, all you have to do is just click on the brand that you're going to take the exam in. In this case, it's going to be SolidWorks, and then you just click on the exam that you want to take. If you don't have the exam purchased, it's not going to say start an exam. It's probably going to say something along the lines of this. So let me just open this image tab. Yeah. So it's probably going to say no credits. Okay. So in that case, all you have to do is just purchase the voucher. If you already have a voucher, then you can just enter the voucher at the top over here, and then it's going to change to start exam, as you can see. Now, note something. Remember when we were talking about the sample exam back in the CSWA website over here? This sample exam? Well, we're going to take a look at it in a moment, but another thing to notice is that, see this free exam, sample exam, that kind of thing? Well, you actually have a free exam to take, which is actually the sample exam of the CSWA inside of this environment of the virtual tester. So instead of just looking at the PDF and looking at the questions and having to answer that on your own, you can actually take it directly from here, directly from the virtual tester in the exact same environment as a real exam, with the questions, with the next button, with the timer at the bottom, with everything. In that case, you can actually see for yourself how the exam environment is going to be, and have some exposure to what that's going to look like before you go sit for the real exam. Okay, and I always advise people to do that. Take the sample exam from the virtual tester, not just from the PDF. Anyways, let's go back. So once you just select one, so you're gonna say, okay, select the language, click start the exam. It's gonna start. I'm not gonna start it right now, but yeah, you know how it goes. So that's basically it when it comes to taking an exam. Now, what's really important is after that, what happens after you take an exam. So let's say you go over here, back again to the website, and then you log in to your account. Let me just log into my account real quick. My monitors are acting up and things are just jumping from here to there. Anyways, here it is. So this is the home page, right? Now I'm logged in. It says my name over here. So what I have to do right now is just go over here to my account. After I take the exam, I will immediately be informed of my result. If I passed it, didn't, and if I passed like with the full mark, what's my score, how long did it take, and so on. And if I did pass, I will also get an email telling me to go over here, log in, and get my certificate. So here's my CSWA. Here's my certificate. I can download it from here. I can download some logos or badges if I want to. I also have this QR code and this certificate ID. Okay, you know what? Let me just zoom in a bit. So if anyone wanted to scan this QR code, it's going to take you to a website that says, we certify that Yahya Tikaj took this exam on this day, and you're checking on that day. And yeah, that's pretty much it. So it's a way of validation to make sure that actually this exam is legit. Same thing with this certificate ID. So both of these can be found at the bottom left corner of your certificate itself. You can find the certificate ID and the QR code. Okay, so anyone can just check and make sure that this is actually a legit exam certificate. So if I take this certificate ID, go to validate certificate, enter it, and enter these numbers 651929, and then hit validate certificate. Okay, 651929. Yeah. Okay, let's just try a different one. 953449. No, okay. That's weird. Anyways, it should say that this is the correct numbers. Let me just make sure that I've got everything correct here. You know what? Whatever. I've tried it before and it worked. No idea why it's acting up right now. Let me try another one.
The website itself is acting crazy.
Yeah. So let's try another one. 8.
Guys, you can see 6, the validation 6, on the 5, screen itself.
7, 6. Yeah. Okay, now, okay, you know what? I'm not gonna do it. Yeah, I'm going to do as Johannes is saying. I'm going to take this, go into like an incognito mode. I'm gonna try it. I'm gonna leave this till I actually try it because this is my certification, and I'm a bit concerned right now. They copy it. It's okay. Let me just go over here. What is it? Where is it? Here's the CSWA. Let me get this ID. And by the way, guys, you can feel free to check it out yourself. Well, I swear I am a certified associate. That's okay.
I watch for that,
guy. Okay. Oh yeah, yeah.
Yes.
Okay. So as you can see, let me just zoom in a bit. It says, okay, this certificate is actually valid. This is the guy who took it. No idea who that guy is. He took the Certified CAD Design Associate exam, CSWA, on this day, so the 23rd of 7, 2020. A bit under 5 years now. And then we're validating it right now on the 29th of 6, 2025. Okay. So just like that, you can validate your exams, your certificates. Not just yours. Anyone can take this code and just validate mine. But it's a way to make sure that this is actually a real certificate, because believe it or not, some people are dumb enough to try and forge these certificates, and it's really easy to catch them. You just try and scan the QR code or just enter the certificate ID, and it ends up with another different name. And yeah, it's hilarious. So anyways, so yeah, actually, it's a good thing that I'm not logged in right now. This is not logged in. Anyone can do this right now. They can come over here and go to the certified users directory. That's really important, because remember what I mentioned about that option, that checkbox while creating the account that says list in the certified users directory or something like that? Well, this is the users directory. If you scroll down here, it says, okay, over here, only people who have that option checked will be shown in this area. And if you do not have this option checked, you know what? Let me show it to you. Let me just make sure that I don't have anything sensitive to show. Okay. Nothing sensitive. Okay, so if I go to my settings, my profile settings, after I log in, over here, list in online directory, let me just zoom in a bit. It says yes or no. Obviously choose yes. And I'm going to show you why in a minute. So let's go back again to the website. But let's say, for example, I'm in Egypt and I want to hire someone from India, from Bengaluru. And I don't actually know anyone there. Sorry, Prasad, but let's say that I don't know anyone there. So I can just go over here and say India. And then I can say, okay, I want someone who's certified. Let's go with certified associate. And it tells me there's 600-ish thousand people who are certified associates all over the world. And in India specifically, well, it's actually taking some time to load because there's a lot. So there's 38,000 certified associates in India. But hear this, there's only 22,000 that are listed in this online directory. Let me zoom in a bit. So imagine this. We're talking about a difference of about 16,000 certified guys are not listed in this user directory just because of that stupid checkbox. Okay, so I can come over here, I can list by city, and I can say, okay, now let's scroll down to okay, that's China. Yeah, here's Bangalore. So maybe I can go with some of these guys who already look like they're certified associates, and I can, okay, so this guy has 3 certifications. He's certified associate in manufacturing and collaborative industry innovator. So maybe that's something I'm looking for, and I can just reach out to him. But he doesn't actually have his contact information over here. So this guy does. He has his YouTube channel, and so on. So this guy has his LinkedIn, and he's got even 4. So that's even cooler. So he's got also simulation. So if you're looking for something like that, you already have it. And I've got his LinkedIn. I can just reach out to him, and I can say, okay, you know what? We're actually interested in someone working for us from Bengaluru. Just do that. Okay. If I come over here to Egypt, for example, which is where I'm from, it's not going to be 38,000, only 4,000. We have to work on that number. But that's even worse. Only 2,500 people are listed over here. So we're talking about like around 50%, maybe even less than 50% are not listed here. And that's because they just didn't check that checkbox. Okay, but most of the people here seem to have their contact information. You know what? Let's search for maybe professionals, and we can also do the same thing in India, and we can see how many certified professionals there are. So worldwide, we only have 267,000. As you can see, the higher the level, the less the number of certified users. And we've got 26,000 certified professionals in India, which is a massive number. But once again, only 9,000 are listed in the online directory. So all of the other, 17,000 people that are not listed on this online directory, they just missed out on a major opportunity to be shown to the whole world and to showcase their skills and their knowledge and how good they are at SolidWorks and what level they are good at. And it's even worse when you go to the expert level. We only have 8,000 certified experts worldwide. 700 of them are in India, but only 500 are listed. That's 200 experts. Experts, that means that he's certified in mechanical or CAD design, sheet metal, weldments, drilling tools, surfacing, mold making, or a bunch of these. But he's not listed on this online directory. So if I go over here and say, okay, I want a certified expert from Bengaluru, let's see. Okay, let's see. Maybe get someone. You know what? I don't think that one of these is going to do the trick. I'm looking for someone with a bit more skill than these guys. Help me out here, Prasad.
I think you still have. Okay, maybe. Wait, I'm still figuring out. I think I'm somewhere at the bottom, probably. I have no idea. I need to check this.
I mean, we're already in Ahmedabad. You know what? Let me just go with the first name and go all the way down to the P. Because imagine if I'm saying this and Prasad is not on this list. That would be very, very bad. So,
because I did not forge my certificate.
Yeah. Okay, here it is. Prasad Adiga. So, as you can see, Prasad, he actually has his LinkedIn, his Twitter, his Facebook. So, he's saying, if you want to reach out to me, here's everything. Reach out to me here or here or here. I'm everywhere because he wants to showcase himself to everyone else. Okay. So actually, Prasad is a very recent certified expert. I was there when he took it this year at 3D as well. So yeah, that's a way to showcase yourself. Now Prasad is one of those 568 people who successfully showcase their skill outside to the other people. Now we have to figure out why we're not at the very top when you go to listing by city. Maybe we can pull some strings or contact some people to make sure that as soon as you go over here to Bengaluru, Prasad's name is at the very beginning. But anyways, this is the point. If you're one of these people and you're not actually listed, well, now you know. You just go to your account, to the settings, and just change that checkbox to opt in to be listed in this certification center. Okay, so what do you guys think? Is that enough, or do you want more? Because I actually have more. Because we talked about some good resources, but that's not all the resources that we have. There are other resources. So obviously, as I said, solidworks.com/TSWA, that's the beginning. That's where you go to learn about what the exam covers. But that's not enough. So let's see what else. If I jump back here to SolidWorks, and let me just close this file. And also close this file. And while I'm at it, let me also close this file. Okay, so when you're in SolidWorks, how many of you have went to this help menu in the top right corner, okay, and then clicked on it and went to tutorials? I want to know in the chat, how many of you know that if you click on tutorials, okay, it's now doing the same weird thing, splitting things across my screen. Let me just fix that real quick. Yep, just like that. You end up with this built-in free offline tutorials. Not just that. If I go to something like basic techniques, I want to apply on fillets, and it tells me, okay, you have to create this part or do this and do that and so on. And I don't actually need to do it. I actually just want to start by applying. You know, I can just click here to open the part. Yes. And it's already going to open the part for me to go ahead and start applying the features on. I don't actually have to create it from scratch and waste my time. And the cool thing is, it says, okay, click fillet in the features fillet. I can't actually find where the fillet is. Well, the cool thing is I can just click on this button and there's the fillet. It highlights it for me. It even goes to the features tab for me. So that's a really cool thing. That integration between these built-in tutorials and SolidWorks is why I always recommend them for anyone. And by the way, if you go back to the main area, you can see the CSWP and A preparation. You can just go through all of these, and these are the things that you're going to need to know by preparation before you go to the exam. Actually, some of these might be a bit advanced. You're not actually going to need sheet metal or 3D sketching, multiple parts in CSWA or Simulation Express, but it's good to know them. So yeah, you've got these built-in tutorials, and as I said, these are free offline, and they're always with the software with the example files, so you can just go straight ahead and start applying everything straight away. You don't actually have to recreate anything from scratch. Okay. Now, the other resource that I also would like to highlight is My SolidWorks. Now, how many of you have used My SolidWorks before? I mean, I see Christopher here has also used the built-in tutorials, same as me. I started using SolidWorks through those built-in tutorials. And I'd love to hear from Christopher how that ended up with him, because for me, it really was the best option. Because if I'm on the go, if I don't have internet, or if I want to check something on my own pace, I don't want to check a video or something like that. I just want to read some text and see some images and see that integration. I have that always with me with SolidWorks. But if you want to take it the next level, if you want to take it one step further, that's My SolidWorks. I'm also going to put that link in the chat. There's mysolidworks.com, and as it says over here, it's your place for all things SolidWorks, because it's not just a resource. If you go over here in this drop-down menu, it says okay, you can search for CAD models. Why go to GrabCAD or any other website when you can just download some CAD models from here? You've got some training, and you can even search SolidWorks forum for questions. If I've got a question, why do I have this zero thickness error? Well, it's going to search the forum for me over here. But anyways, what we're really interested in right now is the training. Because I can come over here and say, okay, CSWA, hit search. It's going to say, okay, what kind of content are you looking for? So there's actually different access levels. A guest is someone who just created an account. You can create an account, come over here, and that is going to open for you the practice exams, learning path, which has the parts, the assemblies, and so on. You're going to have some content over here to check. And if you already have a SolidWorks license, you can actually register that license on your account and open your standard access. And in that case, it gives you some practice exercises for parts and assemblies and a whole prep course and so on. So that's even more content for you to try and use to prepare for the CSWA. Remember, this is all for free. All it needs from you is to just go create an account. And if you're a student, you also have access to this through the serial number that you get from your school. Okay, so this is a really cool resource as well. If you're more interested in watching videos and following up with the video style, well, here it is. Now, let's say I actually want to take it one step further. I took the exam, I find it cool and everything, but the sample exam is not enough. I took the practice content over here. I checked it out, the school and everything, but I still want to take it one step further. Where do you think you should go in that case? Do you know, Prasad, where do you think they should go in that case? Because if you ask me, I would say I would go to someone who has already been through that exam and ask him for advice. And that's what we're actually doing right now. But, you know, I'm actually kind of a busy guy. So what I did is I actually created this website. I'm also going to put it in the chat, linktree.e/journey to the certs. And this is my journey through all the certification from CSWA, all the professional advanced exams, CSWP, and even CSWE. So if you, let's say, click on CSWA, it's going to take you to a link that I wrote. And in that article, it's going to summarize most of the tips and tricks that I've learned and gathered over the years about that exam. So you can go over here and see, okay, this exam, I can divide it into different areas, got some tips and tricks. So make sure to check those as well. And all of these are always ending with resources. Obviously, I have to start with my SolidWorks. There's also some learning content and what I mentioned earlier, the sample exam, which you're going to take a look at in a moment. But once again, even though you can download it as a PDF, you can also take it in the Tangix tester, and that's the way that I actually suggest you take it, because once again, it's going to give you a better feel of what the real exam is going to look like. And at the very end, there's some general tips and tricks that you can also check out. So make sure you check those out as well. But now let's end it with the sample exam. So I've already downloaded the sample exam. It's got a PDF and some files to assemble and create. So this is the PDF. It starts by like a general overview of the exam. So it tells you, okay, the exam is divided into these areas, how many questions are each, how many points are they, and so on, how many points you need to commas, stuff like that. It also gives you some instructions how to download the software, how to launch it, but we've already seen that before. So here is fast questions. Here's the sample exam. So you see, you've got some questions, you've got some options or some choices, and you can like write them down or something. You also have some drawings over here to create. You've got some the same style that you have in the real exam. That's what you see over here. So it says, okay, this is a question. Let's go with part 2, for example. So here's the images. It says, okay, build this part inside SolidWorks. Here's the unit system. So make sure to check out the unit system. Also says, okay, the decimal places, how many decimal places. The point origin in this case is arbitrary. So in that case, you can put the origin anywhere. It tells you what the material is. And just in case, maybe there's like an ASI 1021, maybe 1022. Maybe you fat fingered and entered 1060. Maybe you entered the wrong number. It's always good to double check with the density. So when it gives you the density, inside of SolidWorks, you can also check the density and make sure that both of these are the correct ones. Because maybe in here it's not really that hard, but when you get something like ABS and you find another one called ABS PC, which one is it? You might actually confuse this with that, but the density is going to be the exact number for only one of those, not for both of them. Then you're followed by the variables. So what I would do in that case is I'm just going to go ahead and create all of these global variables, add them inside of SolidWorks, and then here's the question: what is the overall mass of the part in grams? And here it says if it's not within 1%, then you actually need to check, and you've got a couple of options to go through. Okay, so what I have to do is just create this part, check your option. The next question says to modify. So what you're going to do is maybe change A, B, and C. Yeah, A, B, and C, there were certain values. Now you change it to another value, and then you check. Maybe here you start adding different features or removing certain elements and so on. And then it tells you, okay, you know what? Let's now go to the assembly. Here it says, okay, I want the origin to be exactly right here. Nowhere else. It has to be over here. So this is really important because, once again, as I mentioned, later it says, what's the center of mass? And it says, okay, I want X and Y and Z coordinates. And these coordinates are going to be relative to the origin that it's specified, not the assembly origin that you put it somewhere else. It has to be exactly where they specified it in the exam. Okay. So after you finish all of these, there's the answer key at the very end. It's got all the answers, just to make sure that you can double check your answers, make sure you've got everything correct. And just like that, you'll have finished the sample exam. Okay. So once again, I prefer if you take that exam as part of the virtual tester environment, inside of the environment after you log in. That's my personal preference. But either way, you still have the same questions and the answers over here. And at the very end, you've got some hints, tips, and tricks, frequently asked questions. These are really important because it tells you, okay, what happens if I fail? How many days should I wait? What if the computer crashes? Stuff like that. So give it a look. It's really useful to check these out as well. I see someone in the chat asking for the PDF. Well, as I mentioned, all of these are already on the CSWA website. So if you go to solidworks.com/CSWA, you're going to find that download link over there. Okay. And I think we've covered pretty much everything. Yeah, I think we have. So yeah, that's all for today.